I've already posted the review and the answer key in Schoology. So I know we're not going to get to all these, and that's okay, but I do have the answers for all of them up there. All right, thanks. What does this pass?
It's from, because I was thinking of that.
Oh, I wonder where they got these from. These look really old. It's like a carbon fountain pad. Okay, so where's my mouse? There's my mouse. Let's just pick any one of these, like 18 through 21. Let's go with 19. Let's go with 19 because I know a lot of people have had trouble with 19 that were working on it early yesterday.
I had an appointment. She just told me to come here instead of next.
So 19 is negative 1/3 root negative 90. And all four problems in this section are very similar. So I guess my advice is the negative 1/3 in the front isn't going to affect anything until you simplify down the square root of negative 90. So the square root of negative 90, I'm going to break apart. And I'm going to break it apart into the negative symbol as a separate thing because that's going to become the imaginary part. And then, correct, Aaron, 9 and 10. Now, I've been hearing some confusion on this. Who should I go with? Onyx? Sure. Onyx, why did I break it up into 9 and 10? Why didn't I break it up into 45 and 2?
Because 9 is true fraction.
Yeah, I know what you're trying to say. Perfect square numbers.
Yeah,
Yep.
it's a square number of 3.
Okay.
So you can break it down just into 3.
So the only reason we break them down is if one of the numbers is a perfect square root. So I wouldn't break it down into 45 and 2 because neither one of those square roots would give you an even answer and it wouldn't help you at all. So this is considering simplifying because square root of 9 is a perfect number answer. Square root of 10 isn't, so I'm not going to break 10 into 5 and 2 because neither one of those numbers would help us. Like neither one of those numbers would be an even square root. And then the negative symbol becomes I, and then we still have the negative 1/3 in the front. Now everything here is multiplied. If we have multiple normal numbers, we can multiply them together. So I'm going to multiply the negative 1/3 and the 3 together. That'll get me negative 1 I root 10. You can write these in whatever order you want. They'll be correct. I want to say the answer in the book is probably negative I root 10 because the textbook usually writes the I before a square root. I know some of you probably would write negative 1 root 10 I, and that'd be okay too. They're all correct however you want to write it, as long as your information is simplified and the right information. So that's 19. Now, out of anything up here, is there, maybe one of those lines I wrote that you're just not sure why? This particular line, many people do this in their head. And if that's you, you can do that too. Like, there's nothing wrong with doing this step in your head. Does anybody want me to do any of those other ones, 18 or 20 or 21 or anything? Maybe they tried them yesterday and they couldn't figure it out.
Do you do just 18, just like a quick refresh?
Yep. I'll just do it right on it. So 18, the 8 in the front, I'm going to kind of keep separate. And then I'll focus on square root of negative 4. Square root of negative 4, the negative symbol becomes the I. The square root of 4 becomes 2. Just because square root of 4 is 2. And then your final answer, because I have two normal numbers being multiplied, would be 16i. Yeah. Oh, definitely. I was just on this section for right now. Yep. Are we okay with that, Lily?
So you did 8 times 2.
Yep.
Because you multiplied the 2 regular numbers, and then you just took the I and carried it through.
Yep.
Okay, cool. Thank you.
Yep. Should we do the subtraction one really fast? Do you guys need to see that? Okay. So on the addition and subtraction problems, the only thing you ever have to do first is distribute this out to the second parentheses. On the plus ones, there's nothing to distribute. So this one becomes 3 minus 5i minus 6 plus I. That minus sign just makes each one of those two things opposite.
And then you just
Combine like terms. So 3 minus 6 would be negative 3. Negative 5i plus I would become negative 4i.
Wait, so the first thing you just did, on like the top, what changed? Just the plus from the I?
So when you're subtracting a group of things, it's the same as subtracting each of them separately. So this was like subtracting negative I, which made it plus.
Okay.
Multiplication. Let's do 21, I guess. So what is that? 3 plus I, 5 minus I.
Mr. McCloud,
Yeah.
are you available after school?
Maybe. It's iffy.
Like until 3:30?
Questionable.
I'll come in and I'll check.
If you're here right away after school, I'll be here.
Okay, cool.
Otherwise, oh wait, no. I feel like I have something Monday morning. Yeah, we have a staff meeting Monday morning. I was going to say come in Monday morning.
We can't go in before the test.
We've been reviewing for 3 days. So yes, you have been able to get help before the test. I don't know how long the staff meeting will last. So if nothing, you can kind of just be lucky you're in first hour, so I'll be here for a couple minutes at least. I need somebody to help me follow this one through. Zena, I don't think you've been called on forever. Oh, were you asking a question or
Yeah,
volunteering?
I have a question.
Go for it.
So you said that there's 2 parts to the test, or just one?
2 parts of the test.
And you said one is
Monday is going to take the full hour, and you can use a scientific calculator on it.
Yeah.
Tuesday is a shorter part, and you will be using Desmos for it.
Is there any word problems?
Yes,
Okay.
On the
Both
Do we
parts.
go over those? Do we go over those?
they're in the review.
I was not here yesterday.
I have it recorded too.
Okay.
They weren't really word problems yesterday, but I guess depending on what you consider a word problem.
Okay.
But yes, I do have everything recorded. And I'm recording right now for today's party, if you need it. Zena, do you think you can help refresh us on how to FOIL?
Would you go like 3 times 5, 3 times? I mean, like I times 5, and then I again, whatever, just something like that. And then like 3 times the other I, or negative I, and then the I times the negative.
What do you get? What do you get when I multiply those two? But you're right.
I squared.
Perfect. So minus I squared. But good. No. So foiling, I know I use the word FOIL. I don't care what order you guys multiply. So foiling is just kind of a term. I know it stands for first, outs, insides, lasts, and that's a certain order. But the word FOIL, most people just generally recognize it as multiplying things out. So like Zena did firsts, and then no, you did do a FOIL, didn't you? Okay, other people have done firsts, insides, outsides, lasts. It doesn't matter what order you pick. It's just as long as you multiply all four things together, you're good. Zena, somebody you want to call on?
I guess she's gonna go. Combine like terms.
Good. Where are those?
5 and -3.
So 5 minus 3 is 2.
Yeah. 2i.
Okay. Can I do anything else, Victoria?
Yeah. You have to like for the I, the negative I squared. You have to do like -1. Like replace it.
Good memory.
with -1.
Yep, good memory.
And then like combine like terms again.
So this becomes plus 1?
Yeah.
Is that what you're going to ask? Okay. And then so 16. Yeah, very nice. And I'm not going to care which one you write first.
Why wouldn't it, when you combine like terms, why wouldn't it become 2i squared?
So the power would only change when you're multiplying things.
Oh, okay.
So, because the power kind of means how many times it's multiplied.
Okay.
So if I'm adding and subtracting, it's like saying 5 of the i's minus 3 of the i's. It would still be, it's counting up how many of the i's.
Okay.
Would you recommend us memorizing, like what like the different i's would be equal to? Like obviously we know that I squared is equal to -1. That's kind of stuck in our heads. But like the chart we made in the notes, would you?
It's a good question. I did not ask the other teachers yet. I'll probably put that one on the board.
That would be really helpful if you did.
Yeah, I guess I didn't even think of that one. I can put that one on the board.
Okay.
Yeah.
With the +1, don't you multiply?
So what I did was I multiplied the negative symbol times, I guess it's like it's basically like taking -1 times -1. So the black negative symbol that was there times the -1 that's there. It's like multiplying. It's also like saying subtracting -1. There's all sorts of different ways you can view it. It's harder to see when it's simpler. Like if this was minus 6i squared, it's easier to see that you're going to do -6 times -1. And that becomes plus 6. For what it's just easier to see it mentally. But this becomes a plus 1.
Yeah, but on like previous lessons, when we changed the I for a number, it would multiply it to the equation.
We didn't multiply it to the whole equation. We multiplied it to whatever I squared was on. That was the only thing we multiplied it on.
Okay. So if there was a number in front of the I squared, you would multiply it?
Yes. Yep. That like this 6 that I wrote, which was nothing to do with our problem, but correct. Oh, yeah.
I don't know if this is just what he asked, but why did the negative, why did the negative I become a positive? Because I wrote my problem differently, I FOILed it different, so it was a different order, so it was 2i plus I squared, and then that made it
I bet what happened is you forgot. When you take positive I times negative I, it becomes negative I squared. And so I bet you might have forgotten that negative symbol to start with. If this said plus I squared, then it would be a -1. Yeah.
This might be a really dumb question, but would we, is the final answer, is that it, or would we divide the 16 and the 2i by 2 to get the I alone, or?
I get what you're asking. If this was some sort of an equation, I isn't like an x, so it's not something we usually have to solve for. So if it was an x and you're trying to solve for x, then you would do that. Yeah, so this is the final answer. Okay, so somebody wanted division. So let's do 25? Sure. 3 minus I over 4 minus 2i. 25. Jake, do you remember what we do when we're trying to do division of complex or imaginary numbers? Okay, we need to focus on the bottom. Is that going to help jog memory at all? Okay. We need to multiply top and bottom by something. And the something that we multiply by, we get from looking at the bottom of the fraction. So it's called the conjugate pair, which is okay if you don't remember that term. Do you remember how to find a conjugate pair? I didn't hear you. The fan's blowing really hard.
4 minus 2i.
Close. So the conjugate pair means you change the symbol on the I. So we would multiply it by 4 plus 2i. That's what the conjugate pair is. So doing division of imaginaries, that's how you have to do to get the answer. Okay? And then you end up doing a lot of foiling. The hardest part of this problem generally is knowing what to multiply by, because that'll determine everything. So if I FOIL out the top, I get 12 plus 6i minus 4i minus 2i squared. Bottom, I get 16 plus 8i minus 8i minus 4i squared. And then I go to work simplifying things. These cancel. These turn to -1. So on the next line, I'll kind of, and depending on how much you like to do in your head, you know, it could be different for everybody here. 12, I can combine these two together right away if I want. So 6 minus 4. And then -2 times -1 would be plus 2. 16, -4 times -1 would be plus 4. I'll put the 12 and the 2 together. And then 20 on the bottom now. And then we're close to being done. If you know how to simplify it here, you can. Otherwise, I've just been finding most students have an easier time splitting it up to simplify. So we can certainly do that.
Wouldn't it be a -4? Wouldn't it like then go to 12? Because
Minus 4, -4 is there, and then the I squared turns to -1. Did you remember this negative sign?
oh no, I didn't.
Okay. It's for whatever reason, it's easy to forget that negative sign. You're going to ask something?
Well, is it for the plus side, is it plus and minus or just?
No. So the plus and minus is mainly just going to be a quadratic formula. Yeah.
Did we ever do like those problems with like Desmos?
No, that's next.
Okay. Because I don't know how to do it.
Okay, yep, that's next. So I reduce each fraction separately. So 14 over 20 I'll cut in half and get 7 over 10. And since you guys do have your scientific calculators, a lot of them will reduce fractions for you too. There was somebody in this class that had that TI 30, I think, right? I remember.
Yeah, that's correct.
Okay. I forgot to ask on that one, if you type in the square root of 40, will it tell you 2 root 10?
Yeah,
Okay. So it simplifies fractions and everything.
it does.
Okay. So for some of you, that might be helpful. Yeah.
Wait, is that the, do you use that calculator in the first place?
Which one? The one she just held up?
Yeah.
Yep, for sure. So that's considered a scientific calculator. So graphing calculators are the main thing I don't want on the test because they can do imaginary numbers. And honestly, I wouldn't be shocked if some of the scientific calculators can too, but I just haven't seen it really yet, so. Okay, do you need me to do 3i to the 15th at all? Okay, I'll do it real fast because I want to give you some time here, so we'll do this quick and then do the quadratic one, the Desmos one. So 3i to the 15th, I need to figure out what I to the 15th can be changed into. So we look at the cycle of 4. This didn't fit as nice as I wanted it to. And I guess this is what I can put on the board for you guys. So this is the cycle of 4. And all of the I powers will end up being one of these 4 answers. Now, if it helps you, I didn't really bring this up the other day. Do you notice that all of the even-powered ones are normal numbers, and the odd-powered ones are i's? You basically just have to figure out if it's positive or negative. So like over here, I see I to the 15th. I know it has to be this one or this one. I to the 15th, because it goes in a cycle of 4, I'm going to take 15 divided by 4. And that answer is going to be 3.75. If I remember right, this is how you guys liked doing it with the decimal ending. Is that correct? You guys didn't seem to like remainders?
Or you could just multiply 4 until you get a number close to 15, which is 16, and then you just subtract 1, which gives you a multiple of 30.
Yep, you could definitely do it that way too. Like whatever makes sense in your head, do it that way. The 0.75 was the same thing as a remainder of 3, which would tell me I'm going to change I to the 15th into negative I.
I'm so sorry, how did you get 15 over 4 again?
It's I to the 15th.
Oh, okay.
I divide by 4 because it's a cycle of 4.
Yeah.
So then your answer becomes negative 3i. Basically, you just need to figure out what to change the power into.
Could you also, here, let me find it in my notes.
I just don't have time, to be honest. I get what you're saying. If I feel like we're going to have some time after the review where if you want to ask questions, you probably could.
Okay.
Does that work?
Yeah.
Okay. I just want to make sure to get this in and recorded because I know some people were trying to get some things set up. If you're trying to determine by hand, so this is on Monday's part of the test. You're trying to determine if this is quadratic without Desmos. What you were supposed to do is find the differences. So 13 to 11 is down 2, or 11 minus 13. 7 minus 11 is negative 4. Can you even read those numbers?
Yeah.
Okay. 1 minus 7 is negative 6. Negative 7 minus 1 is negative 8. So these are called the first differences. If these were all the same, it would be linear. But this is just asking us if it's quadratic. So then I find the second difference is negative 4 minus negative 2 is going to be negative 2. Basically, it's going down 2 each time. If the second differences are the same, it is quadratic. Go ahead.
If it was linear, would it also be quadratic?
Nope. So it can only be one thing. And if all the first numbers are the same, it'd be linear and you would stop. Because the reason you do that is technically the second numbers would all be 0 and all be the same. So some people would get thrown off by it. Yep.
Will we be asked to see if it is linear?
Nope.
So
Not
that
on this
won't be an
not on
issue.
this test. Yeah. So that's how you do 8 and 9 by hand. They are very fast if you remember how to do them. Okay, should we do one on the left or one on the right? Left? Sure, you guys pick the ones with all the questions. All right, so if you have your own device with, I'd go to Desmos. I'm going to try to move this over.
We do Desmos linear regression.
That's what we're going to do. Oh, yeah, you're right. That's dumb. Why did I even type in Desmos? So this is the phrase I'll put on this. Let me move my coffee, otherwise I'm going to knock it over. This is the phrase I'm going to put on the whiteboard is Desmos linear regression. Not linear, quadratic regression. Did you say linear? Yeah, that's why it threw me off. The reason we're going to Google that is because it'll have one filled out for us. Now, The graph is kind of weird. If that bothers you, fine. I did even find a quicker way. If you just keep hitting backspace, it'll delete whole columns for you. So you don't have to just sit there and delete individually. Now, when I read question 74, this is probably a better example for us to do together because it's got 3 columns. Question 74 says, find a quadratic regression equation to model the diameter given the wire gauge. I'm only going to use those first 2 columns because those are the 2 things it mentioned. It doesn't say anything about resistance. If you look forward, that's question 76. So we're going to use the first 2 columns. Let's type in those 4 pairs. So 24.0201. Oh, what? 01. 22.0254. 20.0320. 18.0403. Okay. Well, that's actually not what I expected at all. Looking at these, the R-squared value is 1. Does anybody remember what the R-squared is for? Because you're going to have to answer that on the test.
How much of a curve it is?
Okay. It represents how perfect of a parabola your points make. Like how perfect of an equation. Now, apparently these points make a perfect one. The number can only go from 0 to 1. If it's close to 0, that means your points don't make a quadratic equation very much at all. If
It
it's
represents
how perfect of a quadratic equation your points make. Because sometimes one of your points might be a little bit off, and so the line wouldn't hit it exactly, but it would predict it close. So the R-squared kind of just tells you how well you're going to be able to predict other numbers. A 1 means we should be able to predict it exactly. Okay, but the equation that we would write down is oh my God, they're so small. 0.000, is that 3 zeros? Okay, 0.0001875x squared minus 0.011235x plus 0.18176. Okay. 75 is also an important question. How would I use my model to predict the diameter for 12 gauge copper wire? Yes, sir. Do you see the A, B, and C underneath it? So that's the A, B, and C you would put on x squared, x, and by itself. It's the same A, B, C's as like the quadratic formula.
So like the number for like A, you just put A, whatever the number for A was in the next one.
Yep, exactly. Does anybody know how to do 75? You would plug in 12. Because the gauge is the x value, you could plug 12 in place of x, or, depending on your equation, we can find 12. Oh, 12 is before, my fault. You can use, I know you guys' trackpad is garbage. So this method might not work very well for you. I don't know if that's true or not. Does it work okay for you to do that? I have big fat fingers and the Chromebook trackpad is worthless to me. So if you can use your mouse to go onto the graph and find 12, my answer would be 0.074. If I plug 12 in place of x, I would also get the exact same answer I just said out loud. So you don't need to do it this way. I just felt like a lot of you would probably prefer to. Yeah, go ahead.
So our answer is the y value of the number given. So like since it was 12 and then like I think it said like 0.
You know what? How about I just type it into Desmos to show you that way? Does that work?
I don't
Okay, so 0.1875 times 12. Where's the caret? Of 6 12 squared minus 0.011235 times 12 plus 0.18. These are such small numbers. And there's our answer. And it's fine with me if you round it or not. It doesn't matter.
So why would you put 12 squared and then not do 12 squared? Is this like going into that?
See these A, B, and C?
Yeah.
A represents x squared.
Oh.
B
got it.
represents x. So that's why I have 12 squared, 12, no 12.
Will you write this down
Nope.
as it is?
Nope, that definitely you need to know. I want to do another question that's not written in 74 to 77. How would I find the gauge if it gave me the diameter?
You could do that and then have that equal to the diameter, that equation equal to that diameter, and then solve for x.
Yep. Does Desmos let you do that? I've never tried.
I mean, you could do it on your calculator.
Kind of. I've never tried it in Desmos. Let's try it together. Well, so say they give you the diameter and they ask you to find the gauge that goes with that. Now this is all for Tuesday's part of the test. But we're not going to be able to review together on Monday, so that's why we're doing it today. And that's why I'm recording it. I forgot a number. 181. If I write that equal to, where's the equal symbol? Let's make up a number that's close to some of those. 0.05. Does Desmos give me answers? No. What did it do? Okay, I thought it would give me answers, but it didn't. What it does is I can use the mouse to find, that's not super helpful though, is it? Well, I'll show you a different way. Oh, where's the line didn't graph? How do I get it to graph? I don't want an equation. I want a graph. Any Desmos experts? Do I have to type y equals? I guess so. So if I type y equals 0.05, I can look at the graph and it'll tell me where they cross. So apparently 16 gauge wire is 0.05.
Are we always trying to find the gauge, or are we only doing that because that's the problem?
Okay, so this particular problem talks about wire gauge compared to how thick the wire is. If they tell you a wire gauge, you're going to be asked to find out how thick the wire is. If they tell you how thick a wire is, you're going to be asked to figure out the gauge that goes with it. So one number goes in place of x, one number goes in place of y.
Okay. So, like, you would, where, like, I'm just so, like, for y, what do you mean goes in place for y?
So
Isn't it just
this equation that we,
squared and then x? There's no y in the equation?
all of the x squared stuff is equal to y.
Okay.
Y is the height or the answer.
Uh-huh.
If you plug in a gauge number, the answer you get at the end would be how thick the wire is.
Okay.
Like we plugged in a 12 gauge wire
Mhm.
and we found out that the thickness of the wire was 0.07394. That's a Y answer, Y value.
So when you put your, like, mouse thing on the parabola at 12, are you writing down that other number?
Correct.
That's the answer.
Yes.
the 0.074, I think it's right.
Whichever method is easier for you, do. If it's easier for you to use the graph, do the graph. If it's easier for you, just type numbers in, type numbers in. Both methods work. So it's kind of all about just using electronics to help you find answers.
Could the answer vary though, because like
Just your rounding, yep.
you have to round it?
I'll know if you did it right. That's all you care about.
Okay.
I'll know if you did it right, and I will. Yep.
So for 74, the answer is going to be the r squared, right?
No, a quadratic regression would be 0.000187.5x squared minus 0.011235x plus 0.18176.
That would be the quadratic regression.
Correct.
Oh, it's.
If it asks you for a correlation coefficient or an r squared value, it'll say that.
Okay, so but the
Quadratic regression,
Okay, the quadratic regression, that's going to be a squared plus.
a
b.
quadratic equation.
Gotcha, that makes sense, thank you.
Mm-hmm.
It's ax squared plus bx plus c,
Mm-hmm.
unless there's a negative.
Well, the number can be negative. A, B, and C could be negative like it is. Okay, I'll stop the recording here anyway, at least.